Hello and welcome along to a video about how I teach the general circulation of the atmosphere. Now I've got to say that this has always been one of my favourite things to teach the classes. I find it very, very satisfying to see those moments when it clicks and when they get it. And it's only really been over the last few years as I've been spending more time on Twitter that I've realised actually for a lot of geography teachers this is anything but their favourite thing to teach. Every once in a while you'll see a message coming up, help, I've got to teach the general circulation of the atmosphere, does anybody have any ideas? So I thought it might be worthwhile for me to share a video going through how I go about teaching it and why I enjoy it so much, and maybe it'll give you a little bit of an insight as to how I do it myself. And one of the key things to start off with is that I'll teach this based on understanding of the application of some key principles rather than simply sitting down and getting them to have to learn it by rote. So it's really involving a little bit of generative learning for them. It's connecting together some of the elements that I've already built in and applying those. So I step them through this step by step, stage by stage, applying each of these principles and working them out with them. So what are those principles that I'll have covered with them previously in the topic? Well, the first and most fundamental thing that I'll say to them is this, that the atmosphere acts to redress imbalance. Now, of course, that phrase might be a little bit wordy at first and it might need explained to them in a little bit more everyday language to get them to understand it. And the analogy that I'll keep using all the way through once I introduce this at the start is this is the equivalent of whenever your parent shouts at you, shut the door, you're letting the heat out. That notion that the warmth will move to areas where it's colder, that imbalance is being balanced out or redressed. And we look at that concept of warm air moving towards cold air. That's one that they will know. We can get this from everyday experience. And the other one is this, that the air moves away from areas of higher pressure towards areas of lower pressure. Now, this one is maybe not everyday experience quite so much, so it needs a little bit more explanation on the way through. And we'll cover this concept with them, that the pressure falls and you've got pressure rising elsewhere. So the falling air gives you high pressure and the rising air gives you low pressure. Now, again, there's bits and pieces we can do to kind of illustrate that for them. You know, if you get this big pile of books, sometimes I'll get a big pile of old weighty textbooks and hold them above the desk a few inches, and it'll drop them down and say, right, that's air falling. So if your hand was underneath there, would you be feeling high pressure or low pressure? That kind of thing. So you can give them something that they can latch on to with that, of the sense of the air falling, giving high pressure, and the air rising, giving low pressure. But of course, once you've got this up, you have got an imbalance. The atmosphere acts to redress it by moving from areas of high pressure to areas of low pressure. Now, of course, that's what generates the wind, but those are those core principles that will get across to them. But we also need to talk in a little bit more detail about the temperature imbalance. There's something quite important that I like to establish before we look at the general circulation. We'll always start off by looking at temperature when we're doing the atmosphere with the students, and we'll discover the startling fact, the most amazing thing that you'll ever learn in geography, that it is warmer towards the equator and colder towards the poles. Wow, aren't you glad you did geography to discover that? So that temperature imbalance, but there's some particular things that we can maybe add to a little bit more detail to that really basic concept that we've already got across to them. And it's based on this map of latitude. Now, this is the Earth Null School website, which is an absolutely brilliant website if you're doing circulation of air or weather. Just go and search it out. It's not only got today's weather in a searchable globe all around the world, but you can zoom in and out of, but you've got an archive going back over years. It's absolutely brilliant. But there's something in particular that I want to tell them about this, a particular piece of information that they need to know. That between the equator and 40 degrees north and south, there is a heat surplus. Now, of course, one of the other things that we'll cover with them in advance of this is why it's warmer at the equator and colder in the poles, and not because the equator is closer to the sun. We'll cover the three main reasons. of the intensity of insulation, the thickness of the atmosphere the insulation has to travel through, and the angle of incidence. And they'll get that concept of it being warmer at the equator and colder at the poles. But this key figure of around about 40 degrees north and south is where you're moving from an area of surplus. Now again, that might be a word that needs explained to them, but you can talk about what that means. And not surprisingly, between 40 degrees north and the North Pole and 40 degrees south and the South Pole, then there is a deficit. So what we have got here is an imbalance. And anytime you've got that imbalance, the atmosphere is going to act to redress it. Now, the reason why this Earth Null School is such a good way of illustrating it is because we have actually got the air circulation on it, and you can actually see this in operation. So if I just slide those over a little bit, and then we've got our surplus and our deficit still there, 40 degrees being the key point, or around about 40 degrees. What you can see here is the warm air going from the area of surplus up towards the area of deficit. And you can see that down here as well, the warm air going from the area of surplus towards the area of deficit. And you can also see, particularly in the northern hemisphere here, the cold air moving from the area of deficit towards the area of surplus. So you can see this reorganization, this movement of air in the atmosphere here, trying to redress those imbalances that exist. So, having established those key principles of the temperature imbalance and the pressure imbalance that we've looked at, and we're ready then to go on to take a look at the general circulation of the air. Now, of course, I've just gone through that quickly. That would be a number of lessons of establishing their understanding of that and really consolidating that through questioning, application, retrieval practice, those kinds of things. But then once they've got that, they're ready to apply those two principles to the general circulation of the atmosphere. So we'll start by this. Where is the warmest place on the planet? It is, of course, at the equator, and warm air rises. And as the air rises, that's going to give low pressure at the surface. Now, they'll also have covered before, whenever we did the tectonics topic, the notion of a convection current. So they will understand that the air then spreads out sideways and eventually cools enough to fall down. And whenever it falls down, you have the high pressure. Now, that's the principle that you've already established with them, but you have indicated that, there is an imbalance here. You've got high pressure here, you've got low pressure here. The atmosphere needs to act to redress that, so how's it going to do it? Well, it moves the air from areas of high pressure to areas of low pressure. Phew, we have rebalanced that. But then, there's another imbalance. This is represented by the color coding down here towards the bottom. You've got the heat surplus here and the heat deficit here. And remember, they've already covered with me that 40 degrees magic number north and south. So what we've got here is still an imbalance because we need to get the warmth away from the area of surplus towards the area of deficit. So let's do that now. Let's send that warmth. Phew, that's another imbalance redressed. We're sending the warmer air from the equator towards the poles. Talking of the poles, if the equator is warm, the poles are cold. If warm air rises, cold air sinks, giving high pressure at the poles. Now, of course, one of our principles is that air will move from high pressure towards low pressure. So you can ask them, is the air going to move towards the poles or away from the poles? Towards or away? Of course, the answer is it moves away from the area of high pressure at both north and south, which brings us then to 60 degrees north and south. Now, if they have covered air masses before, let's say at Key Stage 3 or GCSE, if you're doing this at A level, you'll be able to talk to them about your air masses meeting in your mid-latitude depression, your TM air mass meeting your PM air mass. So they will already know whenever these air masses meet, they don't mix, and the warm air rises over the cold air. And as it rises up, it's going to give low pressure at the surface. And then you can close in that convection cell loop there and there. And that gives you your tricellular model, your Hadley cell, your Ferrel cell, and your polar cell. Now that's all done from the process of the application of those two principles, that air moves from high to low, and air moves from areas of warm air to cold air to redress the temperature imbalance. So basically, having gone over that, I guide them through step by step, and we work through that application. And I make sure that as they're going through, they complete this with me, but then make sure that they understand each step. Now, as soon as I've done that, they draw out that horizontal line again, 90, 60, 30, 0, 30, 60, 90. And I guide them through, this time without me drawing at the front. I talk them through what I've said. Right, where is the warmest place on the planet? It's the equator. Warm air rises, okay? Rise that up, giving what pressure at the surface? Your low pressure, and so on and so forth. So I guide them through, having modelled it, I scaffold them through, and then we just simply do that via retrieval practice, with me asking those key questions over the next number of lessons. And very, very quickly, from the point of the application of those principles, the pupils are able to produce this. But they produce it from understanding. They understand all the elements and understand how they all work together. Now, of course, that allows you, if you're doing it from understanding, to take it a little bit further and make some other connections. So if you have covered biomes at some other stage, you can talk to them about that. Well, there at the equator is your area of warmer air. The warmer air rises, and then that's associated with your tropical rainforest. Then it moves north and south, and then it sinks, and that's associated with your dry desert areas. Then you can move it further north again, and that brings us up to the poles, where it's very, very cold, and you've got your tundra. And then the air moves away from the area of high pressure there, and you've got your polar cell finishing off there, which gives you your temperate forest or your temperate grassland in and around about that area. So you can relate the general circulation through to the biomes. But you can also relate the general circulation through to precipitation patterns that you'll get, because, as you'll cover with them, as air rises, it cools and condenses, and it can hold less water vapor. Condensation occurs, forming the clouds and precipitation. So you can link this in again. Where's the warmest place on the planet? It's the equator. Warmer rises, and that is going to produce conditions that are very wet. Not surprisingly, that's where your tropical rainforests are, moving north and south, and it sinks down over your hot deserts, giving conditions there that are very dry. Not surprisingly, over the deserts. Then that's moving to redress the temperature imbalance. You can go up to the poles again. The air is falling there, so the conditions are very dry, because you've got your high pressure, and the air moves away from the high pressure, meeting at the mid latitudes, where the air rises as the TM air rises over the PM air, producing conditions over the British Isles that are moderately wet. Not surprisingly, we get the wet conditions there. So that's how I go about teaching it. It's all predicated on that notion of those core principles. And if they get that from understanding, then they can take that and apply it to produce the general circulation from understanding, rather than just simply rote recall, which may not bring conceptual understanding of what's happening. And it also enables them to apply it out into things like biomes and precipitation. So that's how I teach it. That's why I love it, and maybe that gives you a little bit of an indication as to why you might grow to love it too.